Hello again. I want to show you an example, of a kinetics of particles where we would use the principle of impulse and momentum to solve this problem. So whenever your force acting on an object is a function of time, a convenient way to solve the problem is the impulse and momentum approach. You could still use second law, but actually impulse momentum for a problem like this is much easier and quicker. So here we have this slider shown here in green under the action of the load in pound, but the load, as you could see, is changing with respect to time. So initially it's changing from 0 to 40 pound and then remains constant linearly and then remains constant. Let's say we are given that the weight of the object is 20 pound. So remember, the weight is 20 pound, but the mass is 20 divided by 32.2, and that would be in slugs. And clearly the crate is sitting on this platform and is at rest, so initial velocity is 0. I want to find velocity of this at t equals 3 seconds. So the end of the interval as shown in the where the load is changing with respect to time. Okay, so in these type of problems, remember that impulse momentum is a way of, it's a vector solution. So if I draw a free body diagram to this, so we have obviously this load acting on the object, and the gravity, the weight, which is in this case 20 pound. And one of the things that you have to be careful with this type of problems is that you have to figure out when does the motion start. And clearly the motion doesn't start right away because initially the load, as you could see here, is 0. So the motion starts, as you could see in this free body diagram, is when P is equal to W. So at least I need 20 pounds, or a little bit more than 20 pounds. 20 pounds happens where? 20 pounds happens right here at T equal 1 second. I mean, if you could not see that, of course, I mean, this is by inspection because we go from 0 to 40 and halfway is 20 and then halfway between 1 and 2 is 1. You could always find the equation of this line, which is clearly just P equal the slope, which would be 40 divided by 2 times T. So by setting 20 T equal 20, clearly you could see time is going to be 1. So motion starts at T equal 1, which means now I'm going to calculate all the impulsive forces, which is the load and the impulse of the weight, only from T equal 1 to the end of the interval to 2 equal 3 seconds. So a typical mistake is that you calculate the impulse from 0 to 3 seconds, and that's wrong. So you have to, your initial condition in a way is at T equal 1 velocity is 0. And right after T equal 1, the motion starts. So now it's very easy to finish this problem. So the principle of impulse and momentum says, okay, change in linear momentum, mv2 minus mv1 as a vector, is equal to impulse. Now impulse is defined as the integral of a force with respect to time, and then of course if the force is constant, that just becomes F times delta T. So if you write this equation in the direction of motion, and you could see that the direction of motion is vertical, so if we take this to be positive, right, so initial velocity is equal to 0. So we have mass. Now remember, mass is 20 divided by 32.2. And then velocity V2 is velocity at that time that we want to find at T equals 3 seconds, equal impulse. Now what impulses do we have? We have two forces here, the impulse of the P and the impulse of the weight. So the impulse of the P has to be done by integration because the load is changing. But remember, the limits of the integral is from 1 to 3 seconds as shown earlier. And then we go ahead, and so this is in the positive direction, and the impulse of the weight is in the other direction, and since the weight is a constant, the impulse of the weight would be just weight times time, force times time, or delta t, and this delta t is also 3 minus 1, which is the 2 seconds. So let me show you how we can integrate or find the integral of p versus t. We really don't have to integrate, we just have to find out what is the area. Since the integral is the area, we just have to find out what the area is from 1 to 3 seconds. So if you do that calculation, the area of this segment is equal to 30 of this trapezoid, and this area of the rectangle is 40. So actually this integral happens to be 70 pound-seconds. That's the unit. And the weight is 20 pound, and delta t is 2 from 1 to 3. So this becomes 70 minus 40, 30. So if you go ahead and solve for V2, 20 divided by 32.2, V2 is equal to 30. So the right hand side is 30, and we should get 48.3, and that would be velocity at t equal 3 seconds. That's 48.3 feet per second. So thanks for watching and listening.